This is the Integrity recording for Chapter 11 from your Horntvedt math book. We're going to be going over calculations using weight and body surface area today. We're going to start by looking at chapter objectives. Again, these objectives will be outlined in that exam blueprint if any of the questions from this chapter will be used on the exam, and they will be, so you'll want to know what your chapter objectives are. When we look at using body surface to calculate dosages, there's a couple of things that we want to keep in mind. We want to make sure that we have the most accurate weight and height for the client, and that we're not just asking them their height and weight and using a weight maybe from a year or two ago. And so we also want to make sure that the scale that we're using, if we're obtaining a weight, is accurate and that it's giving us the correct measurement. Sometimes we're going to have to convert because maybe the order or the problem will use kilograms instead of pounds or vice versa. And so what we will do in some problems is have an extra step of converting pounds and kilograms. Oftentimes in practice, when you're required to do a calculation, we would recommend that you check the dose with either a pharmacist, another nurse that you're working with, or someone else that can just verify that you didn't make a mistake, because a mistake in a dosage calculation can be devastating for any client. And so we want to make sure that we do have our calculations double checked if needed. So we're going to get right into our first example problem, and these first slides are quite repetitive, and I really am just trying to hone in and really teach you the method behind dimensional analysis. So if you're unfamiliar with it, these hopefully will help you to get where you need to be, and they're a little bit of longer problems because I've really got a lot of steps in them and all of the little behind the scenes things, so it takes a little bit longer than it actually does. All right, so our first problem is a provider orders bivalirudin 0.75 milligrams per kilogram IV, one dose today. The client weighs 74.6 kilograms. Calculate the dosage in milligrams of bivalirudin that the nurse should administer. Round the answer to the nearest whole milligram. So just like we learned in that first week's Integrity recording, the first step of any dimensional analysis problem, when we read this problem together and maybe you got a little bit of anxiety just even reading it, let's just start by looking at what are we looking for. Don't even let all the other information confuse you at this point. What are we looking for? And if you look at the third sentence, let me get my little pointer out. If we look at the third sentence right here, our directions say calculate the dosage in milligrams. So all that you need to identify first is what are you looking for. And so your problem will always tell you what you're looking for, because you'll have to be told what the label is going to be on my quizzes and on my exams. So we know we're looking for milligrams. So that's all that you need to do at this point. We need to recognize what we're looking for. So the first step, again, of dimensional analysis is figuring out what your end product is. And so in the book, they use it as a unit of measure. But what I just tell students is, what is the label that they're telling you to figure out? Or if they don't tell you the label, pretend it was an NCLEX question or something. Think about, what are you looking for? If you're going to be administering an IV medication, you're looking for milliliters. You're looking for that liquid. If you're talking about about giving a client a pill, you're looking for tabs. And if you are looking for, let's pretend, usually it's a volume or it's a tab that we're looking for. Or if you're looking for, how to set a gravity drip rate, you'd be looking for drops per minute or drops per hour. And so you've just got to be able to decide what you're looking for. And then the next step then is the given quantity. So I'm going to just walk you through this just in case your mind thinks a little bit different than how our math book presents it. So again, you just have to be able to identify what are we looking for. And so in this problem, we are looking for milligrams. It tells us right here, calculate the dosage in milligrams. So we've got milligrams here. The number one thing you've got to remember when you do math in the dimensional analysis approach, the reason that it's such an easy approach to use and it decreases the amount of mistakes that we see with math, is because you just need to simply take what you've identified you're looking for and you automatically put that right over here. It's always your numerator in your very first equation. Remember, numerator's the top number, denominator's the bottom number. Not things you need to know, but they might be things that I'll mention in lecture because that's how I'll identify the parts of an equation. So you've decided you're looking for milligrams, just put milligrams right here. At this point, you don't even have to continue to get overwhelmed about what's going on because you've totally started out your problem correct already at this point. Now we're at a point that we do need to kind of think about, okay, so we've got our milligrams we're looking for. I know milligrams has to go here. Sometimes then what I'll do is I'll say, look at your problem. And so if you look up at the problem, we only have one piece of information that deals with milligrams, and it's right here. It's what our provider has ordered, and we're using milligrams per kilogram. Again, when we look at this and our problem says a provider orders this medication and it's 0.75 milligrams per kilogram, this is what the doctor has ordered, and you can never change this. And so this is where I say this is a married equation. You will not ever split up this milligrams per kilogram because that would change the dosage that your provider has ordered, and we as nurses don't do that. So you have to keep this 0.75 milligrams per kilogram. That has to always stay in the same equation. So we know that we need milligrams here, and the only thing to choose from in our problem that contains milligrams is this order from the provider. So we know then that kilograms has to go down here. So this is our representation in equation form of what this provider has ordered as the concentration that they would like administered to the client. So this has to stay together here, and by putting it in the same equation here, we've done just that. Sometimes then, after you've got your labels in, then I'll say go ahead and add in your numbers. Sometimes students get overwhelmed if they try to figure out exactly where the 0.75 milligrams goes. You can totally take the guesswork out of it if you just follow this way. Start with what you're looking for, put it up here, match in then what needs to go for your married or your equation there, and then you can add in whatever number the provider has ordered here. So that's your given quantity. We never change that given quantity again because we are not prescribers. We are just figuring out the equation. All right, so we've got that part done. Now what we need to do is we need to add in the second given quantity. And the second given quantity in this problem is that weight in kilograms. And so what we would do is, you might be thinking, well, where does kilograms go? Because does it go on the top or does it go on the bottom? What you need to remember is that with a problem like this, you need to be able to eliminate that label of kilograms, and the only way to eliminate a label is to have it opposite sides. So if kilograms is down here, you have to put kilograms up here. If we would put the kilograms down here, it would not cancel out. And we've got to cancel those out because when you look at what the problem is asking for, the problem is asking for only milligrams. They're not asking for anything about kilograms. That's just that given quantity to help you decide how many milligrams you will administer. So with that being said, we know that kilograms has to go up here because that's the only way that we're going to get kilograms crossed out. So we can go up here, we can put our label, and then we know that by looking at our problem, our given quantity is 74.6. So then there's two ways to do this. You can write 74.6 over 1 if it confuses you not to have a number as the denominator. The other way, which is still correct, would be to just write it like this. The thing to keep in mind if you write it like this or if you see it like this in text is to remember that if there's not a denominator present, then this is basically a numerator. This applies to when you put this into your calculator. And so it's important that you understand that to get the correct answer for this problem, you would just take 0.75 times 74.6. And so if it confuses you with this method by not having the 1 on the bottom, then go ahead and put the 1 on the bottom to make sure that you're not dividing where you shouldn't be dividing. You could go ahead if you're doing this top method and you could divide it by 1, but it won't change your answer. So it won't make the answer incorrect if you choose to do it that way. So either way is completely acceptable, whatever way your mind thinks. All right, so then we've just got to solve that equation and critically evaluate the answer. So again, this is where I said I've kind of got a lot of steps for a simple problem. So we identified what we're looking for as milligrams. We knew milligrams needed to go right up here as the numerator. We put milligrams in. We looked at our problem. We know milligrams needs to go with kilograms, so we added that kilograms in there. Then what we do is we know that kilograms needs to go up here because that's the only way to eliminate, or we will often say cross out, the kilograms. And so we'll put in our 74.6 kilograms. And then we'll go ahead, and this is then where you could cross out and strike through your kilograms to get rid of those. One error that I see as I'm doing this is that this one right here, let me get to my pen. So right here I missed copying this over when I created this slide. This should say 0.75. So you would take 0.75 times 74.6 and you would get 55.95. So now when we move up and we look at what our directions said, we wouldn't want to just put in 55.95. We look at our directions and they say round the answer. Oh, this pointer is not easy to use, I guess. Okay, round the answer to the nearest whole milligram. So when we look at the whole milligram, we are going to make sure then, and we are going to round to a whole number here. So we wouldn't have anything after the decimal point. So if you remember what we talked about in our first week's math orientation, we talked about rounding. And so since this number here is a 9 and it's over 5, we would just round to 56 milliliters. So really important to round your answer as the problem describes. Again, each question that you have for your quiz this week will have a specific instruction that tells you where you should round to, and it will also tell you how to enter it into Respondus, and it will say do not add a label. And so you need to remember that every week for your math quizzes and for your exams in this course, you will never type in milliliters. The box will be labeled as milliliters, and there will be instructions on the problem that tell you do not add a label. And so you would just type in 5-6, and then you would submit that question. All right, so that would be what we would administer to the client, is 56 milligrams. All right, let's look at another example. A provider, let's see, I'm just going to catch up on my PowerPoint here. So a provider orders cyclophosphamide 2 milligrams per kilogram IV, 1 dose daily. The patient weighs 64.7 kilograms. Calculate the dosage in milligrams of cyclophosphamide that the nurse would administer. Round the answer to the nearest whole milligram. So essentially this first part, this part 1, is what we just did for the last medication. So we're going to do that again for practice, but now this problem has another step added. So this will be a new step that we're going to learn together. Now, using that dosage, or however many milligrams we decided the client needed of that cyclophosphamide, we're going to calculate the amount of volume that we will administer. And so we're going to do that with a concentration because our pharmacy is telling us that they have 20 milligrams per milliliter available. So let's go ahead and let's start this one out. So again, we've got to identify what we're looking for, and we're looking for milligrams. So we are going to break this down. So right now we're just on part 1. We're going to figure out what we're looking for. And so that always goes to the left of the equal sign, and we know that we're looking for milligrams. Again, since we've decided that we're looking for milligrams, we know that the very first numerator of our first equation has to be milligrams. So we're going to go ahead and put milligrams in there. And you guys, if you can figure out this step and get your problem started out right and understand how you cross off your labels, that it has to go top to bottom, you will do well with math, because this is the easy, breezy way to make sure that you're putting the numbers into the correct spots of the equation. Okay, so we're looking for milligrams, and we now know that we've got them set up in the right spot. When we go up and look at our problem, again, we've got milligrams per kilogram. We know that this equation has to stay together. It's married. We can't separate it, and so we have to keep it together down here as well. So here it is. We've got milligrams per kilogram. Now, at this point, we can go ahead and we can enter the given quantity from our problem, which is the provider has ordered 2 milligrams per kilogram. So we can go ahead and put our 2 in there. All right, so we've decided we're looking for milligrams. We know milligrams has to go on top. We put milligrams there. We added our kilograms. We kept our couple married. And next, what we're going to do then is we know that kilograms is here, so we have to put it on the top in our next equation because we want to eliminate that. So we're going to go ahead and we've got 64.7 kilograms as our next given quantity because that's what our client has weighed. We used a scale that was calibrated and is accurate. And then we are going to go ahead and again, we have this 2 milligrams here. So we have 2 milligrams. So what you would do then is just take 2 times 64.7. And then what we would do is you do go through the process of crossing out your kilograms, and then you can see you're only left with milligrams here. So when we complete that step, the answer we get is 129.4. Now, when we look at the instructions for part 1, the instructions say that we should round to the nearest whole number. So when we look at rounding to the nearest whole number, we know that we need to do something more with this number. This first place is the tenths place, and so sometimes you'll be instructed to round to the tenths place, and in your instructions then I will have a 0 here, and it's underlined to help you remember that that's the place we're rounding for. The hundredths place would be if there's a second decimal after here. And there will be questions where you'll be doing that as well this semester. So we know that 4 is less than 5, and so we would go ahead and round down. So our dose for part 1 is done now. We've decided that the dose that the provider has ordered is 129 milligrams. That is specific to that client's specific weight. So that's what we will administer. But now we have part 2 of a problem, and part 2 is where they're telling us that they want us to figure out how many milliliters we're going to administer. And so what we need to do is make sure that we know what we're looking for. So at this part, we're looking for milliliters. And if you look back on your slides, if you printed out the PowerPoint, I'll read part 2 to you again. Using the dosage of cyclophosphamide calculated above, calculate the volume in milliliters of cyclophosphamide that the nurse should administer. And so if you were doing this on the computer, if this was a quiz, those instructions would still be right on the screen for you, so you wouldn't have to worry about remembering things like that. So we are looking for milliliters in this problem. Since we know we're looking for milliliters, we're going to go ahead and put that up here. We've got milliliters as our first numerator, and our concentration that was given to us in part 2 says that we have from our pharmacy available 20 milligrams per milliliter. And this is where it's so important for you to understand what you're looking for in the end, because otherwise you may make the mistake of putting milliliters here, and maybe you didn't remember that if you're looking for milliliters, that's what your first numerator has to be. And so if you would put 20 milligrams over milliliters, it would be a wrong answer. So by just identifying what you're looking for, knowing that milliliters has to go up and be this very first numerator, you're on the road to success. All right, so we know that's what our concentration is of what's available, or our given quantity. That's what our pharmacy has available. And then what we know is that in the first part of this problem, we figured out how many milligrams we were going to administer, and we rounded as according to directions, and our number in part 1 was 129. We know that milligrams is down here, so that's how we know that milligrams goes up here. By putting them on opposite sides, it allows us to eliminate them or cross them out. We can reduce them. So we can go ahead then, and again, we would just take 129 divided by 20, and you receive an answer of 6.45. Now, if you look back at the instructions for part 2, the instructions say that you want to round to the nearest tenth of a milliliter, and the tenth would be this 4 place, and just to reiterate again, the hundredths place would be the 5 place. So if you would type in 6.45 to Respondus, you would get this item wrong. We need to round as directed, and so we're rounding to the tenths place. And when we look at this next decimal or this next spot, it's a 5, so we know we need to round up. So the correct answer that we would enter in then would be 6.5. Again, we need to have a label when we do things like this, but on the computer for your exam and quiz purposes, it will tell you not to enter a label. So again, you would just simply enter 6.5, and that would be the answer that you would give for the quiz. And that's how many milliliters we would administer. When we start to look at body surface area, we use BSA because oftentimes that will give us a more accurate picture of a drug dosage. And so there's different ways that we can come up with this using either centimeters and kilograms or pounds and inches. So we will use one of those two systems. And after you figure out the body surface area based on either method, it is labeled as meters squared. And so we will see meters squared used in our problems, and we will see them used in our orders from the physician as well. And whether you're using kilograms and centimeters or pounds and inches, again, very important to make sure that we are using accurate weight and height. One thing to note about body surface area is that this cannot be done with dimensional analysis. So I'm just going to teach you the formula, and then oftentimes once you are able to solve for meters squared, you'll then enter that into your equation, and then that's where you'll use dimensional analysis. There's two formulas that you need to know for body surface area. When we look at kilograms and centimeters, a lot of times we don't use kilograms and centimeters as much in the United States. And so when you look at the formula, the easiest way that I can remember this is I remember that 360 is like 360 degrees a globe. And so I think of this globally, and that's how I remember this formula differentiated from the pounds and inches formula. So either way, we need to understand how to use the square root function of our calculator, and to solve for meters squared with using kilograms and centimeters, you would take weight, which is represented by kilograms, times height. You would divide that by 3,600, and then you find the square root of that number. So we're going to go ahead and we're going to do a problem with this. We're going to pretend like the client has a weight of 93 kilograms and a height of 192 centimeters. We're going to set it up using the appropriate formula. So we know that we need to have meters squared, and to find meters squared, you would take the centimeters times the kilograms, and you would divide by 3,600. So then what we need to do is go ahead and multiply those numbers. So you would just simply take 93 times 192. That gives you 17,856, and then that would be over 3,600. This 3,600 is always the denominator you use when you're multiplying kilograms and centimeters. When we look at our next step, then you're going to divide the numerator by the denominator. So you would take 17,856 divided by 3,600, and that gives you 4.96. And then you want to find the square root and round to the final answer to the nearest hundredth. This is where we said in the Dakota Nursing Program math guidelines it was a little bit different for body surface area, because most of the times you'll round to the nearest tenth. But when we talk about body surface area, we want to round to the nearest hundredth so that we can increase our accuracy while we solve for a solution. So what you would do then is take the square root of 4.96, and that equals 2.227, and instead of just rounding to 2.2, we want to use 2.23. When we look at rounding to this hundredth spot, that's the second spot, and this is exactly how you'll see it on your quizzes actually. It'll say to the nearest hundredth or nearest tenth, and then you'll see it underlined at the place that I want you to stop at. So that'll help to be a reminder if you don't always remember what's the tenths place, what's the hundredth place. So we know that we only need the 2 places for hundredths, but since the number after this 2 is a 7, we round up. So your final answer then would be 2.23 meters squared. Here's how I put it into my calculator. If you're a little bit confused about how you would do this to get the right answer, you just simply would take 9.3 times 192. I don't even push equal, and then you just push divided by 3600. And I do push equal at that point, and then you just push your square root button. So you really want to play around with these numbers and your calculator to make sure that you understand what you're supposed to be achieving. We want to, again, make sure to round to that nearest hundredth instead of tenth so that we can have an increased amount of accuracy. And we want to make sure and round at the end before we get to, not before we get to the square root, again, to make sure we've got the closest number possible. A little bit of a different formula for pounds and inches. One little side note to enter is that you can never use a client's pounds and then use centimeters. You have to either use pounds and inches together or kilograms and centimeters together. You never will be able to combine them. So you've got to stay with either the metric or the English system. So when we look at the formula for this, it's essentially the same. Meters squared equals weight except for in pounds times inches, which would be your height. The difference is your denominator. So this is where I was saying the way to remember it is we oftentimes use kilograms and centimeters globally, and so that's how I think of 360, and then I know that it needs to be a 4-digit number, so it's 3,600. I hope that doesn't mess you up, but that's honestly how I remember it. How I remember this number is that in America, a lot of people really like 31, the 31 brand bags. All the women like we like our totes and all of our stuff for our gear. And so this is how I remember that the USA measurements or pounds and inches, which we mostly use, I think of 31 bags. And so then it's 3131. So these are things that you need to somehow find a way to memorize and remember because they won't be given to you on a quiz or on an exam. And so these are the methods that worked for me, and I just wanted to share them in case they would help you as well. Okay, so here we've got a problem that tells us to calculate the body surface area for an individual with a weight of 153 pounds and a height of 68 inches. So we just want to make sure we know our problem and we know our setup. So we've got pounds here times inches, and we know we have to divide by 3131 because we are using pounds and inches. So then we would do is take 143 times 68. That gives us 9,724. We would divide by 3131. What that gives us then is 3.11. So then you're going to have 3.11 in your calculator, and you are going to take the square root of it. So then what we get is 1.7623. There's a little bit of a difference now. If you would have left the number in your calculator after you divided 9724 by 3131 and then pushed the square root button, there would have been some numbers after here. And that's usually what I do because, again, it's the most accurate. But your book does tell you to just round to the hundredth here. So no matter what number you received, I will have, sometimes there will be 2 right answers for a quiz or an exam item based on if you rounded like the book rounds or if you left the number in your calculator. I am one that leaves the number in my calculator because, again, it's the most accurate way, but there are times that'll change the answer, and so some quiz items will have 2 correct answers because both ways are technically correct based on how your book teaches you to do it. So if you have a question on that, you can let me know, but if you're either following the book or how I do it in the PowerPoint, you'll do fine on the quiz. So when we look at this, then we know that we need to round this to the nearest hundredth. It tells us right here, round to the nearest hundredth, and so your correct answer would be one of these 2, and in this case it turns out that they both would be reduced to the exact same number. When we look at this thousandths place is below 5 either way. So your correct answer then would be 1.76 meters squared. Again, this is how I put it in my calculator if that is an area that may confuse you. 68 times 143 divided by 3131 equals, and then I just push that square root button. So we're going to do some calculations to figure out how we can identify a dosage based on the body surface area. And an example that we have is a provider orders acyclovir 750 milligrams per meter squared IV 3 times daily. The client weighs 75 kilograms and is 162 centimeters tall. The pharmacy supplies acyclovir in a 20 milliliter vial containing 50 milligrams per milliliter. So let's just start with our first step. We need to calculate the dosage in milligrams that the nurse should administer. However, before we can do that, we do need to figure out what that body surface area is. And so what we're going to do is keep in mind our formula. We've got meters squared equals. Now, our problem is using kilograms and centimeters, so we need to use the denominator of 3,600 here. So we take 75 times 162, and we get 12,150, and we divide that by 3,600. You see here then that we take the square root of 3.375, and our answer becomes 1.84 meters squared. Now that we've done this step, we can go ahead and continue on with part 1. So what we need to do is calculate the dosage in milligrams that the nurse should administer. I went in and I had a lot of steps for those first problems, but now I'm going to kind of just walk you through. I feel like I'm hoping you have a good basic understanding of dimensional analysis by this point, and so let's just break it down with the numbers already in place. So we need to figure out milligrams. It says calculate the dosage in milligrams. So we know milligrams has to go here. Since milligrams is what we're looking for, milligrams has to be our numerator at this point. And when we look at our problem and what we're given, milligrams is paired with meters squared, and we know that they're a married couple, so we can't split them up. They have to stay together. They have to be in the same equation. So then you can do your meters squared, and then at this point you could enter in your given quantity that we know that we have 750. 750, I guess, when I look at this slide, it maybe is a little bit confusing. They're probably, the line maybe should be over a little bit more here, because 750 goes with milligrams. And so that's your numerator. That's not at all tied to your denominator. All right, so then what we do is we have meters squared here, and that's perfect because we had meters squared that we figured out using our formula, and so then we can cross out meters squared here and here, and we entered in what our body surface area was. And so then you would just take 750 times 1.84, and your answer is 1,380 milligrams. All right, so now let's go on to part 2. Part 2 tells us to calculate the volume that the nurse should administer. And so when it says calculate the volume and it tells us we want milliliters, we know we need to start out our problem with milliliters here. Milliliters goes to our numerator, and then we need to look and see what milliliters is paired with in the problem. And right here we've got 50 milligrams per milliliter. Again, this is what the bottle tells you. The manufacturer tells you the concentration in the bottle, and this is the bottle that your pharmacy has available to you. So you cannot change this. You cannot ever separate these numbers because there's no way to change the concentration of the medication in that vial. So once we've decided milliliter has to be on top, we know that then we have 1 milliliter per 50 milligrams, and then we'll go ahead and we'll enter our answer from step 1. And so we identified that we were going to administer 1,380 milligrams. So at this point, this is where I said you could put the imaginary 1 down here if this confuses you that we're talking about a numerator here. So then you would just take 1,380 divided by 50, and we get 27.6 milliliters. When we look at what our directions for rounding, it says round to the nearest 10th milliliter, and that happens to be exactly what we came out to, so we were lucky. Okay, let's do another example. When we look at this example, we are doing the same thing. We are going to figure out our body surface area, and then after we've figured that out, we are going to identify what the dose is, and we are going to identify then how much we would administer. So a provider orders rituximab 375 milligrams per meter squared IV once weekly. The patient weighs 64 kilograms and is 158 centimeters tall. The pharmacy supplies rituximab in a vial containing 10 milligrams per milliliter. Calculate the dosage in milligrams that the nurse should administer and round to the nearest 10th milligram. Let's just focus on step 1 right now. So again, we know we need to figure out how many meters squared because our provider has told us in this problem that we're going to give 375 milligrams per meter squared. But our provider did not tell us how many meters squared the client is. However, we know this information of kilograms and centimeters, so we know that we'll be able to figure that out. All right, so again, our calculation for body surface area is right here. We're going to go ahead and take 64 times 158, and we know that that goes over 3,600. So we get 64 times 158 is 10,112, and when you divide that by 3,600, you get 2.81. When you take the square root of 2.81, you get 1.68. All right, so now we're going to use dimensional analysis. So let's look back at this problem here. Calculate the dosage in milligrams that the nurse should administer. So when we look at that, we know we're looking for milligrams. Since we're looking for milligrams, milligrams has to go up here and be that numerator. Again, I'm not loving the way that this equation is showing up because I'd like to more clearly see here that this all is a numerator here. Okay, so we know that when we looked at our problem, the provider has ordered 375 milligrams per meter squared. So we have to keep that together, and we have to keep the milligrams with meters squared, and we have to have this 375 right here then. So when we go ahead and enter in our meters squared then, we know that meters squared can be canceled out by putting another meters squared at the numerator of the next equation. So when we put in our 1.68, and then we can cross out our meters squared, and then that's perfect because we're left with just milligrams here. So 375 times 1.68 equals 630 milligrams. Now, sometimes on a quiz question, it may tell you round to the nearest tenth. If you come up with a full answer like this, even if it tells you round to the nearest tenth, you would never, ever, ever add a tenths place. Those directions are there just in the case that you would have had multiple numbers left in your calculator. You would never go and write 630.0 just because your problem identified to round to the nearest tenth. That only applies if you have more places than your tenths. So you would never ever do this again because somebody could miss that tiny little decimal and they may misinterpret the number for 6,300 milligrams. So never ever going to do that. So we're going to just get rid of that so it's just not even there. All right, so let's go ahead and let's do the second step. Then what we need to do is calculate the volume in milliliters. So again, when we look at calculating the volume, we are able to identify here that we have to have milliliters, and when we have to have milliliters, or we're looking for milliliters, we know that that needs to be our numerator here. When we looked at our problem, let's go back to it just to give you a refresher here. It says that the pharmacy supplies rituximab in a vial containing 10 milligrams per milliliter. This is again on your math quizzes where you would have this right on your screen in front of you. You wouldn't have to scroll back and forth. So when we look at that, we know that the pharmacy has this vial, and the vial tells us that we have 10 milligrams in every milliliter. We can't change that. We can never separate that. That has to stay together. We know that milliliter goes on top because we're looking for milliliters, and so that always has to be our top then. So we'll go ahead and enter that 1 over 10, and then we are going to go ahead and multiply by our answer that we got in step 1, 630 milligrams. And since we have milligrams on the top, we can go ahead and you would be able to eliminate your milligrams, and you would take 630 divided by 10. So we would get 63, and then our label left is milliliters. So you would have 63 milliliters. Okay, that's the end of the Tegrity recording for this week. I hope that this will help you with your workbook that you were assigned to do this week for lab, and I know that you will do great on your quiz this week if you're able to do the problems in the workbook via the method that I've demonstrated on this PowerPoint. So, good luck.